Hello everyone and welcome to the 18th episode of the StackToHeap podcast. In this episode, we have with us Nivedha, who's a senior consultant at ThoughtWorks. Today we'll be talking about an interesting library called Taiko, which is a library for testing web applications, and it has some pretty interesting features that I could see that distinguish itself from very lot of other similar tools that are there in the space. So I wanted to get some more context on where the inspiration for Taiko came from, what's happening with it, what are some of the core features of it, what were some of the challenges that the team had to face to address some of the design principles that they had while building it, and then talk a bit about what is the future for Taiko, where it is heading, and so on. Hey, welcome, Nivedha.
Hey, hi.
Hey, thanks for taking the time to come on the podcast. So, can you start by quickly introducing yourself, what you work on generally?
I'm Nivedha. I work in ThoughtWorks as a developer. It's been almost 6 years since I started my career, and I currently work as a developer in Gauge and Taiko team. Yeah.
Okay. Yeah, so can you expand a bit about Gauge? What is the setup there like before we begin talking specifically about Taiko?
Gauge is a test runner that aids writing tests in a natural language. We can write our specifications in Markdown, and then the implementation can be written in any language runners. There are many language runners like Python, Java, JavaScript. So depending on what your application needs, we can write the implementation in the language that needs. So Gauge helps in orchestrating tests and generating reports. So the main purpose of Gauge is orchestrating the automation test, like at the end-to-end test. Gauge aims at testing end-to-end flows like functional tests and API tests.
Cool. So can you talk a bit about what Taiko is and what is how you are involved with Taiko itself, and also a little bit more on it evolved within the context of Gauge also, right? In a way. So
Yeah.
how did the idea for Taiko come up, and how did it
So
all start? Yeah.
so for making the process of end-to-end testing smoother, so we wanted to introduce Taiko. So most of the UI automation tests that are written using Gauge uses one or the other automation tools for writing functional tests to automate UI. So many a times users used to face a lot of problems like maintainability and flakiness in tests. So for making this a smoother experience, we wanted to introduce Taiko. So Taiko is a browser automation tool that focuses on testing. So Taiko is inspired from Helium, a tool that has a simple API, and it has a interactive REPL like how Taiko has now. And Taiko is also inspired from Puppeteer, which interacts with browser using Chrome DevTools protocol. Uh, so since Taiko uses Chrome DevTools protocol, it can be used against any browser that supports CDP, like Chrome or the latest version of Microsoft Edge, Opera, and even Firefox has a partial support, and they are adding more support and making it stable. They are adding support for CDP currently. So that's how Taiko started. Even to be more precise, Taiko was initially a wrapper over Puppeteer, and then it moved towards adapting the protocol directly.
Okay. So we obviously know there are tools like Selenium and so on, which are there in the space. So what would you think as the libraries that are closest to what Taiko is doing? And once we have established that, so what do you think are the main features that at least we aim to differentiate it from these other tools? And what are the core distinguishing features of Taiko?
So since Taiko aims at solving problems like test maintenance cost and flakiness, the main feature in Taiko, I would say, is smart selectors and proximity selectors. So how would we can reduce the maintenance cost. So when I say maintenance, it's like going and rewriting our tests again and again. So most of the time what testers end up doing is whenever there is a change in any DOM structure, like say if an ID is changed or a CSS class is changed, and then the functional test would start breaking even though the functionality is intact. Which is an unnecessary burden on testers to simply go keep on changing the selectors, which is not actually affecting the functionality. So smart selector comes into place there. So those are all based on text searches. So it tries to mimic as much as possible how user would actually interact with browser. So if we have to go instruct a user to click on a button in a page, how would we say? Something like we would say, please click on a button with label click me. So that's how an API in Taiko would also look like. It would be very similar like that. So we would simply say click button click me. That's how the command in Taiko would also look like. So Taiko tries to mimic how user would interact with a web page, so that it abstracts out the underlying DOM structure, and it can make the tests more stable. And proximity selectors also helps aiding this. Like using the proximity selector, we can select any element based on its vicinity. If you want to select, if there are two buttons having the same label, then how would we differentiate that? We can then say click this button below these wordings or something like that. So proximity selectors can be used by telling, like you can select an element near one or above one, or to the right of, to the left of, like that and all. So that is one main core feature in Taiko that differentiates it from other tools in this space. And the other feature that
Just to when we say other tools in the space, right? I did mention Selenium. So could you expand a bit on that, so that especially to others listening also, and to also to my mind, we know exactly which are the tools that we are comparing with. So
so
would something like Cypress also come into picture? Yeah.
Cypress,
Hmm.
Puppeteer,
Hmm.
and Selenium, and tools that are based on Selenium like WebDriver
Hmm.
IO. And
Hmm.
recently, Selenium has also said that they are going to adopt proximity selectors because of an inspiration from Taiko. Yeah.
Oh, nice. Good to know.
Yeah.
Yeah,
So
I think I personally haven't written a lot of them, but I do write and maintain these functional tests. And I think the biggest one is a lot of times when the tests do fail, it's failing mainly for some trivial reason, or maybe because nothing really changed, but you might have moved things a bit or changed a selector here or something like that, right? So
yeah.
yeah, good to know. I think, and also sort of surprising that it's not being done already. Is there any other tool that does it? Is Helium that you mentioned something
Yes,
that was
it
doing
is
it?
inspired from Helium actually. Yeah.
Okay, okay. So to talk a bit on the implementation, right? So what were the challenges in implementing like proximity selectors? How difficult was it? What are the primary challenges when you had to face when designing an API around proximity selectors, and were there some corner cases or some cases where you found like it was pretty tricky
Yeah.
to get the right thing? And of
So
course, to expand a bit on that, do you also have? I think there should also be then once if something cannot be achieved, actually do use the normal CSS selectors or something like that.
Internally, if we see, all those are implemented using CSS selector within
Yeah.
Taiko. So we abstract that out for users. So there were a lot of corner cases for the text search. Say if you have to say. Say for example a button, it can be a button label or even the value in the input field. So Taiko has to figure out if the rendered text is actually a label for that button, or if it is an value, or if it is a child node within that button. So it can be anything that can be rendered as a button. So there were so many cases which we had to handle, and that were all added based on user feedback. And still there are edge cases like where the DOM, a normal div being painted like a radio button. So when we say a radio button in Taiko, we actually look for input field with type radio. But then in with modern JavaScript frameworks, it's not the case really. Any div can be painted like an radio button. So that's where proximity selectors come into picture. When we say click next to click link next to some radio button label, then it would really find what is to the left of it, and that's where it plays a major role. When we don't really have to go look into if it is a button or if it is really a radio button or if it is a link. So it all were built based on user feedback whenever there are some edge cases missed. Yeah.
So other thing I wanted to ask is we talked about the Chrome developer protocol, right? So how has it been maintaining a library on top of it? Has it been a pretty stable protocol? How are things with working with that?
Yeah. So Chrome DevTools protocol, like it keeps evolving constantly. So we have a abstraction over that. So there is a library called Chrome Remote Interface that we use, which actually takes care of all the WebSocket calls. So all the communication between Taiko user script and browser is based on WebSockets. So Chrome Remote Interface takes care of all the WebSocket calls, provides the protocol as API to Taiko, which we consume. So since the protocol is also evolving, the greatest difficulty we found is proper documentation and examples for what we are trying to achieve. Most of the time, we actually end up looking at how Puppeteer has implemented certain features to understand how the protocol actually works. So that was another pain point that we had. Uh, uh, like we'll have to really go look into some browser implementation. Like say one of the main feature in Taiko is implicit weights. So for implementing that, we need to know what are all the requests that are being triggered as part of an action, and we should wait for those requests to be completed. So for this, we had to actually go deeper to understand how browser actually handles network services. So when we say a request is complete, what are all the states it can be, like a response is received, or the request would have been aborted. So for understanding all of these, we had to really go read about Chromium's network services. So it was that detailed where we had to go. And it was actually a great learning process also, since we understand more about the browser, we were able to provide better resolutions for that. So which can make our tests less flakier when we actually wait for better actions.
Yeah. Yeah, I think waiting for requests or dynamic XHR requests and content to render, I think, and not handling those correctly are one of the other reasons for tests to start breaking. So, yeah, interesting to know that the framework itself does some intelligence on it to make sure tests are run in a more optimal way, right?
Yeah.
Good. So, does the underlying Chrome protocol help with some of these aspects, or it you had to go, like you said, into the details of understanding it? Does it make a bit easier? How was the development experience around it?
So it was actually nice using the
Hmm.
protocol. Like anything that happens in the life cycle of the browser, we get the details about it. Since Chrome DevTools protocol is a two-way communication, unlike the WebDriver protocol, which is one way, we get to know about the events happening in the browser then and there. Like we'll know if there is any tab being opened at the moment that it is happening. And we'll get to know about even the rendering life cycle of the page. Like we can even take advantage of that to like wait for the first meaningful paint that can happen, instead of simply waiting for the load of the page, which will even make the tests more reliable and make sure that even all the fonts and other XHRs are all loaded properly. So that really helps making the tests more reliable, which is one pain point I see in other tools that uses WebDriver protocol. This allows us take advantage of browser settings. Like you can change the network condition. You can emulate the network condition on runtime. We can test changing the network condition, like going on offline and changing it to 2G or 3G at runtime, and even emulating devices. Like with WebDriver protocol, we'll have to do it as a capability, to add it as a capability to the browser driver, and it can be done only once. But with the DevTools protocol, we get an advantage of doing it anytime in between. And also it provides a very great power by letting us know the request and responses. So Taiko also provides a way to intercept those requests and response and mock them if needed. So it brings down a big overhead on testers, like creating a mock server. You can completely mock the server without creating any mock server. You can simply write a one-line API which would say mock this request and return this response. So that kind of power is given by the DevTools protocol.
Nice. Yeah, I think all that makes it very interesting, and I actually want to try it out. So one thing that I wanted to ask is, you were mentioning about offline applications and all, right? So coming from a context of a progressive web app and service
Yes.
workers, are there any specific approaches that people do for testing with service workers? And does Tycho provide any bells and whistles to do like testing what a service worker is doing and all that?
Uh, Currently, there is no
Mm.
direct API that Taiko provides, but still, we can anytime take advantage of DevTools protocol using Taiko. So Taiko also has plugin architecture. So
Mm. Okay.
since we wanted to leverage all the power of DevTools protocol and also keep the core Taiko focused for the UI automation, uh, we can always take advantage of Taiko's plugin architecture. So there are few plugins like Taiko Diagnostics, which aids us doing performance metrics and all. And there is plugin called Taiko Storage that helps us accessing the local storage and memory management in the browser. So we can always take advantage of the DevTools protocol using Taiko's plugin environment. And also, if user wants to do some one or two take advantage of one or two APIs in the protocol, they can take they can use it with the client API. So Taiko exposes the client API, so the user can always take advantage of that. So there is currently no specific APIs for that. Yes.
Right. Yeah, all that sounds interesting. Like I said, I do have a Cypress-based testing framework for a current app that I'm working on.
Yeah.
Probably will try out to see how Tycho compares. And yeah, it sounds like it's going to be making things much easier. I did look at the features on the website a bit. Yeah, sounded pretty interesting. And so after speaking with you, I think it feels like something that I should try out. Yeah, thanks a lot for those information. So just coming to the final question for this episode. So, what does the future hold for Tycho? What are some of the upcoming features? What are the primary focus for the team? Where can we see this product going?
Okay. So the primary focus that we have is making our error messages more self-sufficient for users to like fix them by themselves. So we are focusing on giving prompt error messages so that they don't come back to us, that the messages itself is sufficient for them to fix it. So that's our focus. And also we are constantly trying to cover all the edge cases with implicit weights. So definitely the hypothesis that we have currently is not sufficient for making the test completely reliable. So we try to cover as much as possible, but still there is always scope for improvement. So we constantly try improving our implicit weights. So that is there. And we currently added support for shadow dom. That is one of the major feed that we reached currently. So like we said, Taiko tries to consider the web page as implementation of web page as a black box. So this is one of that. So we currently added support for considering shadow dom elements as a normal element, how an user would see. So we are waiting for feedback on that and improve much more on that.
Nice, good to know. Yeah, so something new for me to try. So thanks a lot, Nivedha, again for taking the time and talking to us, Taiko, and good luck with the project going ahead as well.
Yeah, thanks a lot. It was great. It helped me actually reinforce and learn about, like, think about what Taiko is really. Thanks for the time.
Yeah, thanks. See you.